Okay, so if all of you guys can see, today we're going to be talking about the introduction to logic controls. Now, it doesn't explicitly mention it anywhere on the lab that we're going through. However, I want you guys to start thinking about these concepts because this is the basis to make very complicated systems. And if you get the building blocks right, everything else is going to go super simply. Pretty much this in relays, and you're off to the races. So over here, I've drawn two rivers, and I want to talk to you guys. So there's a gate here, gate 1, and gate 2. Same idea here, gate 1, gate 2. So we'll put this one, 2, 1 and 2, and 1 and 2. All right? So what this is this is kind of like a logic chart. AKA, if I say 0, 0 is going to mean that this gate is currently open. If I say 1, it means that gate is down, okay? Now, if I have gate 1 and gate 2 both open, am I going to have flow on the exit of this?
No, 0.
So if this one's open and this one's open, sorry, give me a second.
Close.
You know what? I said it backwards. Let me re-say that. If this is 0, the gate's down. It has 0 height. And if it's 1, it's open. All right? That should change some things, okay? So if this one is at 0, it's closed. And this one's at 0, it's closed. Do we have any water flow? No. So then it would be 0. So if we got 0, 0, then we have 0. All right? Now what if I have this one up and this one down? So we have 1, 0. Will we have flow at the end?
No.
No, because this one's blocking it, right? So that's going to be 0. What if we flip the script? This one's going to be down now, and this one's going to be up.
Still 0.
Still 0. So if we have 0, 1, it's also 0. But if we have both of them up, what's the output going to be? 1. We're going to have flow at the end, right? Great. 1, 1, and 1. So let's talk about this one first, and then we'll go on to the other one. Would you think if I gave you the name of two gates, one's an AND, one's an OR, what do you think this one would be called? AND? Yeah, because 1 and 2 have to be open for there to be flow on the outskirt, right? Great, so we're going to call this an AND gate, and that's 100% correct. How does this translate into a circuit? Well, it's really simple. Instead of gates, we're going to have switches, and the wire is the stream. So we're going to have, I'm going to show you guys a new way to look at circuits. So far, you've just seen kind of like you have the positive, the negative, the positive, and it goes around to power things, right? Whatever the case is, right? That's what you guys have seen. We're going to replace this with 24 volts, and we're going to replace the short line with 0 volts. And that's going to be 2 lines, but not looking like that. I'm going to redraw it properly in like 2 seconds. Okay, let's get this. Now, here's a few good things for housekeeping in general. Whenever you're drawing or wiring from 24 volts, use red. Whenever you're going back to ground, use black. Whenever you have a schematic on your circuit, whatever it is, you want to lay things down exactly the way they are on the schematic on your table. It's going to make your life really easy to be able to build your circuits and get through everything you want to, okay? And also you want to keep in mind the flow of your current. So if we have here 24 volts and 0 volts, we got a little line there and a little line there. Our flow of current is going to go from the left to the right. Have that same mentality in your circuits, and it will make it so easy, because then it's like if you have 2 switches and they're in parallel, you always just connect the left to the left, the right to the right, and it's done. You don't have to think about it. And if you start to go all the way around and do weird stuff, you have to do like severe mental calculations to figure out where it's going. And the more complicated your circuit gets, the crazier it's going to be. So make it easy for you, make it easy for the person working on the circuit after you. Keep things simple. There's this very simple rule. It's called KISS, K-I-S-S. Keep it simple, and then I'm not going to say the last one, but you guys know what word starts with S. All right? So we got here this one. So we said it's going to be 2, switches. So we're going to use SPSTs. So that's 1, that's 2. And then what's the output? I don't know, maybe a light bulb, right? So let's put a light bulb over here. So what we're going to do is we're going to connect this to this, and this one to that one, and that one to ground. We don't really need these hanging wires. These hanging wires are great for when you're designing circuits and drawing them by paper. As soon as you move to Automation Studio, don't use them. It's not part of a professional circuit. You just have the actual circuit outline, right? So from here to here, here to here, here to here, and back to 0. Now, how are we going to have this parallel this? If this one and this one are open, so 0 and 0, what's the light going to be, on or off? Off, exactly. If this one's on and this one's open, if this one's closed and this one's open, off, still off. If it's the other way around, this one's closed, this one's open, off. And if we have both of them closed, on. Fantastic. Welcome to an AND logic in circuit form. Now here, down here, we're going to ask you guys the same questions, okay? We're going to go a little bit quicker because I think you guys got the hang of this already. If the top one is up and the bottom one is up, will we have flow? Yes. Sorry, we said backwards. One is up, right? So if this one's down and this one's down, will there be flow?
No.
No. Okay, so 0 and 0 give us 0. How about if one is open and the second one is closed?
Yes.
Yeah, so we got 1, 0, 1. How about if we flip the script?
Yes.
Yeah, so if we got 0, 1, 1, and what if both of them are open?
Yes.
Yeah, so 1, 1, and 1. What do we call this guy? Or. You guys are good at this. O-R. Okay, so we have our and, we have our or, and how does the or play out over here? It's pretty easy. Let's do the same thing. So we have our 24 volt here, 24 volt. We got our 0 volt here, 0 volt. We're going to draw our power lines, and we're going to have, instead of them in series, we're going to put them in parallel, okay? So we got number 1 over here, switch 1 over here. Under switch 1, we got switch 2. And we got our light bulb in line with switch 1. This goes from here to here. This one goes from here to here, here to here, and this one goes to ground. And if we're being super professional, we'll take off that extra line over here. All right, so same questions. If these are both open, is the light on or off? Off. Okay, cool. If this one is closed and this one's open? On. If this one's open and this one's closed? On. And if this and both of them are closed? On. You guys got it. You guys already got the serious fundamentals of logic controls. That's pretty much all there is to what I want to talk about. Again, it's not going to ask you specific questions about and or anything like that, but I want you to think about the concepts while you guys are building. Yeah. And if you guys have any trouble while you're trying to build your stuff, come to me, and I'm going to do a quick demo over there just to show you guys a really good way to build circuits, okay? Cool.